Thank you, Sophie, for that introduction. As Sophie mentioned, my name is Lorena Mireles. I am an Elixir developer at Erlang Solutions. And today I'm going to talk about troubleshooting, about some concepts for tracing and a good example with Elixir. But the talk is mainly focused on the Erlang fundamentals behind those concepts and that tool. This is my first Simplex ever, so I'm really excited about it. But thank you. Yeah, so I'm excited, but also a bit nervous. If I say something that doesn't make sense, assume it's that. Unless it's related to the Erlang, because we know everything makes sense there. Following the tradition, I'll start with a main introduction. About me, that's my full name. I've been a backend developer for about 10 years, but I started working with Elixir in 2018. I came across to the language by chance. Someone told me about a magical functional language, and I said, why not? Let's learn something new. And since the beginning, I loved how easy and intuitive things can be. So almost 4 years later, here I am. And I hope to continue exploring and learning. I work at Erlang Solutions. I have a degree in computer science from UNAM. I'm Mexican, and I love coffee. So if you want to continue the conversation after the conference, that's my Twitter handle. If you want to talk about random stuff, dogs, or coffee, drop me a tweet. And having said that, welcome officially to the talk, Erlang Fundamentals for Debugging Elixir. I'll start with a brief historical context. Take a look at this picture. Maybe some of you haven't seen it before, but if not, he is an Ericsson engineer troubleshooting an Next-10 telephone switch. Each wire represents a subscriber, and he was looking the one that was failing. And the first time that I saw this image, I always react like this, because I laughed, like, no way. Thousands of subscribers, and just one of them is failing, we can live with that. But I'm not in the telecommunications industry, that's clear. So jokes aside, we're talking about switches that not only generate a lot of money for the company, but that also are vital. Because the law stated that you had to be able to call emergency services at all times, which means the penalties for the outages were huge. And because of that, Ericsson had troubleshooting strategies for these cases, for troubleshooting live systems without affecting the performance and the other users. And they brought the lessons to the Beam, and we're gonna talk about it. Yeah, the picture looks crazy, but it's only thousands of subscribers. And I say, only 1,000, because current systems can handle more than that. Do you remember this Phoenix experiment? They were trying to reach the limit of the connections, and the result was 2 million of simultaneous connections. So imagine this in your system, and with the example, one of them is failing, so imagine how long it's gonna take that. But even if it sounds extreme, troubleshooting is easier than you can imagine, especially for the Beam systems, and that is because the Erlang tracebays. So we're going to explore that. Erlang tracebays are built-in functions that have been battle-tested for at least 20 years and are the foundation for the Elixir and Erlang tools for tracing and debugging that we know. The main two functions are this one, trace and trace pattern. Trace allows you to enable and disable the tracing mechanism on the Erlang virtual machine and allows you to monitor a lot of things like code execution, concurrency, garbage collection, function calls, global and local function calls. And it receives 3 parameters. The first one is the process ID that you want to trace. The second one is a Boolean that enables or disables the tracing mechanism. And the third one is a list of trace flags that are your conditions. And trace patterns, on the other hand, allows you to enable and disable the function calls. Like I say, global and local. This might look simple, but it has a huge potential because this, in conjunction with something that we call match specifications, are the foundation for those tools. And it's something really powerful. In this diagram, I'm showing that you need to use those two functions in conjunction. So if you want to define a processes subset, you can define the processes and also the functions with that trace and trace pattern. And you will generate events from the intersection. If a trace process executes a trace function, you will have an event. Like I said, it looks really simple, but it's super powerful. And I won't go too deep into match specifications because I think the concept is pretty intuitive. They work basically as a filter. So you can define the conditions that you want from those events. But I'm going to show you an example. With those functions. So far, just with Erlang trace. And in an Elixir shell, I'm using flush, so you can see nothing on the mailbox. And then I enable the tracer with this command. The first parameter is not a process ID, because you can also use a wildcard. And in this case, I'm indicating that I want to monitor all the processes after I enable the call. I'm indicating that I want all the sent and received messages by a process, then a hello MPEX, and I disable the tracer with the same command, but the second parameter is false. Indicating that I want to suppress events, which means to stop the tracer. And then I use flush again to get the detail. No, I don't want the video again. And it's something like this. What we're seeing here are all the messages between the shell and the group leader. So as you can see, everything starts here after I enable the tracer and all the send and receive messages. Okay, this is a bit of theory, but we also have amazing things in Elixir that are working like a wrappers, so we can use them. And time to introduce Rexbug. Rexbug is an Elixir tool that is like a wrapper. It's based on the Erlang debugger, the Erlang Redbug library, sorry. And allows you to monitor live systems and get information from it, modules, functions, and you can also specify the conditions that you want, like the filters. You can use it like any other dependency. You just add it to your project, and you start it with the command start. And one of the biggest advantages of this tool is that the tracing events are limited. So even if you don't stop the tracer at a certain point, the tracer will stop. Or you can also define a number of events in a specific time. And this is really, really an amazing advantage because it can be something critical. I'll share with you a story. I don't know what's happening with my slides. Here. Well, there is someone that enabled the tracer for all the events. So imagine if you have a system like the Phoenix example that I mentioned, and you have millions of users, and you don't consider that you want the events for a specific subset, you just enable it. And I took this from the book Erlang Programming, and it's a story about a nationwide outage because this person enabled the tracer for all the events. So what is going to happen with that is that you will have a lot of shell printouts that disable typing the command to stop the tracer. And the system will run out of memory. The performance will definitely be affected. Do you know who's this person? He's not here, but if you don't know, he was the keynote for the first ever MPEX, Francesco Cesarini. You can ask him about this story. It's a funny one. But, well, with Rexbug, you don't need to worry about it. And I'm not trying to scare you. What I'm saying is that we have really powerful foundations, and the tools are amazing. But if you're going to use them, you need to know what you're doing. You need to know the fundamentals and specify the conditions to avoid these cases, your filter, and also because with 1,000 or million of users, there are many events that are not relevant to us. We just need the one that is failing, and that's it. Okay, so far it has been a lot of theory. When I was a student, I hate having programming classes without seeing any code. So today I won't be what I sought to destroy. I'll show you a mini code example with Redbugs, and then we'll talk about the advantages. Another video. It's a mini Phoenix application that is going to simulate like a shopping cart. Everything is hard code, and it's a basic application, so don't judge that, the complexity. But the point of this is if you have a lot of users and you're looking one that is failing, you can define that user specifically and the function and the module that you are interested in. So in this case, I'm sorry if I typed wrong. I didn't want to record again. So the username is any string. And then I'm interested in a function that is calculating the total of a card for that user. And we have an error. So I want to see what is happening. This is the function. And I was expecting an atom with an OK and with the total price of the card. So I can use Rexbug. Is, like I say, I added like a dependency, and then you can start it with a start command, indicating the module and the function that you want to trace. In this case, it's just the general function, so I'm not specifying any username yet. I can specify the time, because like I say, it's gonna die after a certain time. So in this case, 10 seconds, so we can see the result. And here you can see what is happening. You can see the trace for that function. It's requesting the get user function, then the get by user, and then it's an error. So I can have an idea what is happening with that, because I was expecting that after the get by user, another different request here. I was expecting the calculate total. No, the user is valid. So I can see that function, and I can check the blocked user, which in this case is the error. And I can also define the same pattern, but now specifying which user I want to validate. This is slower than I thought. OK. Here, so I define, where's my instruction? I'm tracing the other function, the user is valid. So first, with the username that is failing, and I can see there is an error. If I try with another username, that one is valid. So yeah, that function is the problem, but this is a very simple example. So what I'm trying to show here is that if you have complex systems and many functions, this is super helpful for that. And you can also do it instead of like the general function with the parameters that you're looking for. So right now, I'm going to specify the username, and I'll show you the trace for that. Like that, like I'm expecting this username, so this is what is happening. And then I request the function. Oh. And you can see the trace there. Like I said again, same result, but now you have the specific username, or you can define whatever that you need. And you're going to see all the requests here, here, and then the errors. So you can find really easily the point where it's failing. And when I used this for the first time, I was like, OK, and then what? Like, what do you need? What else? Like, no, it's that, just like that. Like, but this was super easy. Like, no, probably I'm missing something. And no, that's it. You can find the errors. You can define the patterns that you need. You can do it more complex, but it's super easy to use. You can just add the dependency and there start tracing live systems. And like I say, without affecting the performance, you can even forget to stop the tracer, and you're not going to cause any issues performance. This looks really simple, but it's super powerful. If you have a system like the example, or like any other system, where is my mouse? Like any other system with thousands or millions of users, imagine the time that you can save with these tools. And also, if this is not enough, you can also have the mechanism to develop new tools. So I want to focus on the fundamentals because those are the key to develop new tools and to invent crazy things. Something that I enjoy from the community is that there are always new things. You can always share something different approach or improve something, refactor, whatever. And that is because of the Erlang fundamentals. So we have really powerful tools, but we need to know how to use them. We need to be aware about all the advantages that we have. And instead of cause nationwide outages, we can, sorry, is he gonna watch this? Francesca, I'm sorry. But we can use advantages of these things, and we can explore with them live systems without affecting anything. So even if you have millions of users, this just takes like less than 1 minute. Imagine that you receive a call in the middle of the night that something is failing. And you just use this and take less than a minute, you fix it, and you can continue with your life. So it's also an invitation to explore the fundamentals. I didn't talk about much specifications because, like I said, they were like a filter, but it's a powerful filter. And mini commercial, if you want to learn more about it, you can use the Erlang programming book. It's an amazing resource for that. I think that's it that I want to talk about it. Just invite you to explore all these things and take advantage and see the power in action, because you can use it with any system, and it's super easy. This is like inclusion. I think that life is too short to explore random crazy stuff when we have Erlang and Elixir, and we can develop more things. So use the fundamentals for this, take advantage of them, and explore the powerful things that we have in the community. And just to top it off, I want to say thank you to some friends that encouraged me to send the proposal, because like I said, this is my first MPEX, and I was super nervous and also technical talk, but I think this is an amazing event to start with that. So my friends, Raul Chosa and Johanna Larson, and my colleague, Francesco Cesarini, because he helped me a lot with the preparation for this talk. The organizers for having me, and also my family, because they will be expecting the mention. And that's it. Thank you so much.